So I want to thank everybody for spending your lunch hour with us. Don't know if we're going to take quite an hour since it will be a one-way conversation here, but we'll give you a really good amount of detail of common functionality within SolidWorks 2015. It's going to be the types of things that in some situations, no matter what you use the software for, these features are definitely going to be beneficial for you. So I just want to make sure that everybody gets a good experience out of this. And again, we'll probably keep it to more around 45 minutes to an hour and get you back on your way with the rest of your day. But once again, I appreciate you spending your valuable time with us. So we're going to go ahead and just kind of use the PowerPoint for a couple of prompters here, but I'm not going to spend too much time on this. Today's session is really going to be more focused on the design functionality, not necessarily the details of the CAD, but how the CAD can help you, how SolidWorks can eliminate button picks and really streamline the things that we've done. Even early software functionality has been readdressed with some of these new features. So we're going to start out with basic user interface. Once again, it doesn't matter if you make parts or assemblies or 2D drawings, a lot of these functionalities are going to be quite beneficial to you. So let's just go ahead and jump right into the live portions of the demonstration. So on screen, we're looking at the SolidWorks assembly currently. And when a SolidWorks assembly is on screen or a part file, we've had this tool that we added a couple of releases ago called the View Selector. And you typically get there by holding your control key and hitting the space bar, and it brings up this cube that shows around your part or assembly. Now, two things that have changed in SolidWorks 2015 would be the fact that if you hover over any one of these panels, it's going to show you a preview of what that view is going to look like before you actually select it. Now, a difficulty we used to have with this tool previously is that it would also shift you into an isometric mode, and this back ISO that you can't get to, you never were able to get to. But now this is non-modal, so we can actually go ahead and rotate this tool while the view selector is active. If I want to get to this back angle here, we'll just go ahead and select it, and it will roll our assembly or part around to that position. There is a way to also couple this with your view orientation dialog box. That's the space bar that brought that up. If you click this button here, then the view selector will also show when you click your space bar for any named views or standard views that you might have. There is also a button that can be added to the heads-up toolbar, so if you just want to click it there and then go ahead and deal with the view selector in that manner, that's fine. If you decide to click in the background off the view selector, it will simply return you to the view that you were at when you last used it. So over in the Feature Manager, we've got a couple of hidden components, and previously in assemblies the only way to know what these parts were was to physically show those. Well, now if you just simply click on those, what you're going to get is a nice transparent highlight of them. Now if I click off of it, of course the transparency goes away, and multi-pick is going to show multiple hidden parts with that transparency. In this case, I'm just going to show those components and bring them right back, but it's a real nifty way to not have to physically show a component that maybe you don't need, and you just want to figure out which it is in the tree to action on it properly. When dealing with parts, multi-body parts specifically, or assemblies, there could be a lot of extra scenery here. Here we've got a lot of bearings and other internal componentry on this file. And I want to isolate things. Now, isolating is a really quick way to work on just what you want to deal with here without hiding and showing or making configurations. And I've always been able to isolate by right-clicking on a part and simply going to isolate. But now you can actually isolate from a common mate. Now, because we're doing it from a single mate, there's multiple components associated with that. So with an isolate here, it's going to get rid of all the scenery and details inside and leave us with those two housings for this particular assembly. This also works if you're already in edit part mode within the assembly itself. Now, the Feature Manager, anybody that's used SolidWorks or really any other CAD system that's parametric in nature for more than a short time, you've already realized that there are parent-child relationships set up within the product. Now, these parent-child relationships are something that you can visualize by simply going to any feature in the Feature Manager and doing a right-click, and that option's always giving you this thing that's called List External References. Well, now what you can do is just simply hover your cursor over top of one of those. So if I happen to be editing a part within this assembly and that we're focusing on this feature tree, if I right-click on any of that, List External References is a tool that we can go ahead and show. But if you just simply pause while you're panning over top of one of these features, these reference indicators are going to pop up automatically. Now, it used to happen immediately in beta, so we've put a little pause on it now, but as you hover for about a second and a half, you'll see this parent and child scheming show up here. Now, some of these arrows actually show with names. If I look at Boss Extrude 2, for example, you see the arrow going low, shows motor floor, but it's pointing to Boss Extrude 3. Well, the motor floor happens to be the sketch that's absorbed by that feature, and if that feature was shown, then that arrow would not indicate the name of it since it's not buried beneath another feature. These can be turned on and off if you'd like. I doubt anybody's going to turn them off with that pause we built in. But if you right-click on the name of the assembly at the top, that's a button there for the dynamic reference visualization that would allow you to physically pause that feature or turn it off. When customizing the interface, we've had the ability for quite some time to customize, of course, the toolbars that we have here and hotkeys and even what menus show. But there's a couple of toolbars that have not been customizable, and one of which is this right-click toolbar in the graphics area. You typically get zoom, rotate, and pan functionality. We've also added this time around, though, is a nice quick toolbar here for some quick select functionality. So here we have lasso versus box select. We've got selection filters, which I'm going to go ahead and grab the face selection from this at this point. But it also gives you some other nifty ways to get to these selection tools, including our power select tools, which essentially are a pull down that's been across the top here for quite some time. So I've got my faces selected. Let me do something with that for you. There's a situation I'm sure everybody has run into where you've done a very meticulous selection, whether you're window selecting with your control key, whether you're simply control picking multiple things. These could be edges, sketch entities, a lot of different things. And there are times at which the pick gets so meticulous and maybe even a mispick takes place. You click and you deselect all that stuff that you took the time to pick. Well, now there's a right-click option that shows up on this quick toolbar right in the middle here, simply called Previous Selection. By clicking that button, it will activate all of the entities you previously had selected before you clicked off of those. Now, if I click off them again and right-click and Previous Select again, they are still the previous selection. So it's a really great way to get out of a situation that, again, I'm pretty sure everybody has faced, and I know I've faced from time to time. There's also an option that really allows you during these meticulous selections to save and group those selections for later use. Now I'm editing this part file, so right now the parts feature manager is active. What I'm going to do is just go ahead and grab a couple of faces. And by doing this, I'll right click, and there's a new choice here called Save Selection. What this creates is something called a selection set. So over in the feature manager of the part that's currently active, I have 3 different ones that are showing up, one of which is the new one I just added. And by clicking on these different things, you're going to see a pre-grouped selection set. So in this case, we might have been picking these faces as a precursor or setting us up for simulation, maybe adding loads and restraints. This one over here, I just clicked and showed you how to do it. But we'll do this in assemblies later and any other place that you would do a multi-select that maybe you only want to do once and never have to actually do again. Selection sets are something we borrowed from one of our sister products, SolidWorks Composer. So a pretty cool thing. All right, let me get out of this face filter tool for a minute. We don't need it anymore. I'm going to right-click on the part, and here again we have another toolbar that's been created by the developers, but really based on what we feel are the most commonly used features. Now we actually have the ability to right-click on this toolbar and customize it. Now by doing this, we're customizing one called the graphics area. Now on your shortcut button, if you hit S on your keyboard, you also have part, assembly, drawing, or sketch mode shortcut toolbars that can be customized. But for this particular one here, I'm just going to go ahead and add our whole wizard to it so you can see what this looks like. Adding it to this graphics area toolbar and saying OK means if I right-click on the part, you'll see whole wizard is there. But if I also right-click in the graphics area and get that quick toolbars, any customizations I make to the graphics area toolbars will also show up right here. So we're going to click the whole wizard in this case, and I'm not really going to get too meticulous into the details of what we're going to deal with, but I'm going to go ahead and add a nice M6 hole right down here. So let's go ahead and grab our M6. We're going to do a counterbore on this guy here. That looks pretty good. And then we'll just go ahead and throw this over on this face. So we've got a bunch of other M6 counterbore holes over here. And what I wanted to get into specifically with this is a little bit of new functionality changes that had to do with Toolbox. Now for those of you who haven't used Toolbox and do have professional or premium licenses, it's definitely something that you should take a look at because it's a really great performance enhancement tool for adding the fasteners into your parts and assemblies. Now we've added some new functionality as to how you can actually display these. So if I go to my design library and click on Configure Toolbox, which is something you can also do from your SolidWorks Programs group, what we're going to bring up is the Toolbox Customizer. One thing that we've added to this is the ability to drill down into any standard that you'd like, whether it's a top-level standard folder or right down into the fasteners beneath that. And when you get into these different fasteners that we've got here, we now have the ability to customize the configuration names of each of these. Now previously versions of SolidWorks, you'd see this column would actually be grayed out. And it's all by turning this checkbox on or off that makes that active. So customizing configuration names is important because when you use Toolbox components in an assembly, the assembly's bill of materials typically by default is going to show configuration names. So you want these to be customized or specific to your using. Now on top of that, if I go over here to my defining user settings, we also have controls for how to display Toolbox components within the feature manager versus a bill of materials and a unique granular control to each of those. So right now I have mine set to show the name of the part in the feature manager as the file name, and then when we look at the bill of materials on a drawing or the assembly, frankly, we can show the configuration name. Now by doing this, this is the effect that we get. Let me get into my toolbox, show you how fantastic this is. I'm going to grab that little crossed panhead screw. What's great about Toolbox is when you drag a part off of the toolbox, it has a default size. And if you hover over a hole, what it's going to do is auto size to whatever hole you've placed it on. So in this case, it's dropped it down to the standard size that's there. If I drop it inside this hole, again, it auto sizes and auto places concentric and coincident to that hole. Then it gives us the manufacturing purchasable lengths for that particular fastener. So we don't have to select something that's unpurchasable or something that we would then have to manufacture. Now once I've said OK to that, I now have the option to smart mate several other instances of that. So just by clicking inside these holes, it's automatically putting a concentric and coincident mate between my fastener and the hole itself. If you look at the feature manager now, what we're seeing here physically is the name of the part file. Now of course in parentheses you see the configuration name, and that's always been pretty typical. Now if I go ahead and add a bill of materials to this, and yes, I'm adding a bill of materials to the assembly file, which is not new functionality. It was actually about a SolidWorks 2007 function. If we go ahead and drop that bill of materials in, what you'll see down here is a quantity of 5, but it's showing those M6 fasteners as their configuration name, so that specific granular piece of data. So that is the first portion of what I wanted to show in this part of our What's New presentation. So back over to PowerPoint for just a moment. The next thing I want to cover is what we call direct editing functionality, and this is the capability to edit featureless parts within SolidWorks. Featureless parts could be from anywhere. They could be neutral files, they could be native CAD files that come in without features. But in any event, what this really comes down to is that inside of SolidWorks, we have the ability to edit, and have for quite some time, parts that do not have any parameters. No sketches, no dimensions, they just happen to be bodies. Now the way you do this takes many different forms, and the typical way is this button up here that's called Move Face. Now Move Face is usually shown through the Insert pull-down menu, down to Face, and down to Move. But in this case what I want to do is take this grill, and we brought this in from, I believe, Unit Graphics, but it really frankly doesn't matter in that case. We're going to go ahead and we're going to modify the lengths of these instances here. So to take a look at that, let's just go to a right side view. And I want to select all those faces, which when you do this, a little window select is kind of demo magic in this case. It allows me to window select, but in essence I've selected all of those faces in line with each other. So you can do that in pretty much any feature within SolidWorks. So now what we're going to do is just go ahead and translate these faces. So from the side view, we're presented with a triad, which we weren't in previous releases. You can either type in the dimension or just go ahead and drag the triad's proper axis. Of course, with any other feature, you're going to get a preview. Now, we don't only have the ability to do a blind end condition, but we can also go up to features. So now you see we have up to surface and offset from surface, as well as up to vertex and body. We'll do body next. We'll turn on this plane, and then that plane's going to end up being the surface we're going to extrude up to. So we've got to fill these two boxes in properly. First one we have is called the from face, and the second is the to face. The from face then is the same as the flat faces that we're translating. Now anywhere that we have up to surface, we also have its counterpart, which is an offset from surface. And here we're presented with an offset dimension. You can either use Instant 3D to drag that on screen. We can just go ahead and type in the number. We don't need that plane. So let's go ahead and take a look at it from a different direction here. In this case, we're going to go ahead and use the same tools, but we'll do an up to body end condition. So in this case, we'll go ahead and grab this face. And instead of translating at a distance, we'll use the proper end condition up to body. Now, as it translates, it's going to hit this solid body, multi-body part in this case. And it gives us that nice little bird's mouth that you get as two round pipes, like a bike frame or a tube steel frame, come together. You can see that the shape is created. And that's something that we could end mill or use a ream or some sort of laser cutter to go ahead and take care of that. Alright, let's go ahead and zoom out a little bit. Now we've created history with this, which is one of our really powerful features when it comes to direct editing. It's direct editing, but with feature history involved. Therefore I can go back and make changes and see how these features were created. I use this frequently on native SolidWorks parts as well as other imported parts. And the key is features like these have patterns. And without regard to feature history or parent-child relationships, you can use these direct editing features to just simply move faces. I don't care how those sweeps were created, but I certainly don't want to upgrade that sweep path if it was a native SolidWorks file. Here, just a simple drag will take care of that. Now, if it happened to be a SolidWorks native part, we'll also go ahead and interact with individual instances of a pattern with these same types of inputs. So if a resulting feature needs to be updated, you can deal with it on a one-to-one basis. Okay, let's switch over from multibody to our sketch tools. And sketch tools have been in the software since the beginning of the software, almost 20 years ago. But what we've done is gone back and readdressed something that is the basis for the product. And in this case, nothing is immune to being enhanced. So we're going to show you how we can remove button picks and workflow using the same steps that you do today, but with a drastically improved series of clicks that we're going to have less interaction, less need to exit a tool, and then get back into that tool in order to go ahead and select features to add relationships to. There's a new sketch feature, and then there's also some other tools that allow us to walk through these processes in a more cohesive workflow. So we got an existing part here. Let's just go ahead and edit this feature. We'll get down into the sketch. And I'm going to start off with just removing some of the data that we have over here on the left-hand side. So we'll just do a little window select for that. First thing we're going to draw is going to be a tangent arc. Now the tangent arc, as you know, is going to add a relationship from the originating entity, its adjacent entity. But where it ends is kind of up to where the geometry around it is. In this case, when we end this arc, we're going to immediately be presented with the capability to add the relationship to the second entity. In this case, it's going to be tangent. So instead of exiting and then control picking the line in the arc to add that relationship, we can go right to it after completing the arc itself. Really a great improvement when it comes to the series of button picks necessary for these very common repetitive tasks. Up here, let's do a line. It's the exact same thing. We'll draw a line up to the end of an existing line, and we're immediately presented with horizontal and vertical for the line itself, as well as collinear and perpendicular and parallel. So we can go ahead and go right to the relationship of perpendicular to the adjacent entity. Now instead of a line, let's go ahead and draw a style spline. Style spline over here is going to allow us to create the tangency in the beginning, but where we end, once again, is not perfect. Therefore, with a style spline, we're presented with perpendicular, curvature continuous, and tangency. So class A versus just an ordinary tangent. Existing entities also have the same effect. With the select tool, if I pick a couple of points between two lines, I can go directly to perpendicular. And down here, if I pick a point between a line and an arc, I can go directly to tangent. No need to select both of those entities. So over here we've got a couple of other entities I want to deal with. Down here we have a line. When you select on a line, you're going to be presented with the most likely orientation. In this case, it's closer to horizontal. Therefore, horizontal is highlighted. Now you always got to keep an eye on the origin, because even though it's horizontal on the screen, it doesn't mean we're not looking at this sketch on its side. And if we were looking at it on its side, then that would actually indicate a horizontal, even though we're physically looking at it as vertical. So don't underestimate the power of that feature walking us through the orientation. In this area, we're going to go ahead and add a dimension. And we added a release ago the ability to add dimensions to center lines and have it hold the center line persistency. Well, now we're doing that with angle dimensions as well. When you dimension to a center line, there's a high likelihood that's going to be an axis of revolution. So we've got a little bit of a behavior that we can add to this now in order to deal with the dimensions of what is essentially a 2D sketch. So here when we go ahead and add in the sketch dimension, as we hit our Shift key on the keyboard, we can take the dimension from an angled line to a center line and have it automatically double. That way when we input it, it's doubled now, but as the part gets revolved, it ends up being the complete dimension as we need for the drawing. Now next to my cursor there's a center line with an A, and what this is indicating is a persistence of the selection of that center line. So if I didn't even see that center line, I could continue to select other sketch geometry and have it automatically select that center line for me. Of course, the Shift key is going to go ahead and give us that transition over to the full dimension. Now even though that persistency is on my cursor, if it's not what I want for the next dimension, it doesn't fight me. I have the ability to go ahead and select an entity, which will then put the dimension to the center line. But if I just want it to go to another piece of geometry, all I have to do is select that geometry and it will let go of the persistent selection of the center line as it was. Simply add the dimension, and now we're just dealing with the basic linear dimension. All right, let's see if everybody can hear me still. Okay, we are back. Had a little bit of audio difficulty there, sorry about that. So we're going to take a look over in this area here for just a moment here, and I got a new line tool that I want to show you. And this one here is simply called the midpoint line. If we go ahead and select our line tools, what you're going to see here is our midpoint line tool. And on screen here, this works a couple of different ways. First, if you do a pick and drag functionality, it's going to go ahead and continue to draw midpoint lines. So if I do pick and drag like an AutoCAD methodology, it'll draw this midpoint line. And then if I do another pick and drag from that endpoint, I'm ending up with a midpoint line at the midpoint of that line. Now, if we take this a little differently in more of a Windows aspect, we'll do a pick and release type of method, or excuse me, more of an AutoCAD aspect. Down here, what I'm going to do is just simply go ahead and draw that line in with a pick and release. And then I'm going to go ahead and pick and release to end it. And that'll actually transfer over to a standard line tool. So in this case, because I probably wouldn't want two midpoints touching each other, in this case, we just go to our regular line tool, and that allows us to continue to create the geometry of the rest of the entities. You see as I delete these that we have up here, what we're actually going to see is a couple of midpoints that are actually added. Those are point tools, similar to the point that we have up here in the sketch tools. For rectangle tools, we've added a bunch of functionality here that has to do with construction geometry. And a while ago, what we actually had was the ability to put in construction data with only one of our rectangle tools, the midpoint one. But now with any rectangle that you'd like to draw, you have the capability to determine construction geometry, and then if it goes from the corners or the midpoints. So a little bit of control on each of those. So no matter how you like to draw your rectangles, this is going to work for you. Here, if I go ahead and draw my rectangle in, I'm going to simply type in the dimensions as I draw this. But these midpoints are really effective because it gives me a selection point where I can drag that around, snap it to other geometry if necessary, and that puts everything exactly where it needs to be with little interaction. Down here, what we've got is a line. And with this line, I'm going to go ahead and actually chop this up into multiple lines. We've had a tool for this for a while as well called the Split Entities tool. But we've kind of added a new functionality to this and made it a new tool called our Segment tool. Segment tool allows you to select any sketch entities that are out there. And with those sketch entities, essentially I have the choice of either adding points to these entities or chopping them up into segments. So here, if we go ahead and put 6 segments in there, it'll take this perfectly good line and chop it up into 6 equal and collinear lines. So it adds relationships to it, keeps the behavior the way that it is. Now what's important about that is the fact that if you do nothing else, your functionality, your behavior, your design intent's not going to change. But if you do come in here and select, say, this line and simply delete those relationships, the other ones will still maintain their relationships as 5 equal length lines. But in this case, I can then go ahead and action individually on the other entity. We'll come back to that in just a moment. Here we have some construction entities. We've long had the ability to right-click on solid geometry and do something called Select Chain, which grabs all the touching sketch entities regardless of tangency. Well, we can now do that on construction geometry. So here, if I right-click this construction line and simply say Select Chain, it'll grab all of these entities that touch. Now this one here, these don't touch at an endpoint, so that's why they weren't selected. But it allows you to then right-click an action on this. In this case, I'm going to switch it from construction to solid geometry so it grinds off the end of this feature. That looks pretty good. Now there's one last thing that I want to deal with, and that's over on this end. And that's that segment tool one more time. With this line, what I can do is go ahead and use the segment tool, and in this case, just simply add points to this geometry. That'll throw sketch points on this as it would with a bolt hole circle. Now it doesn't fully define them, it does add some coincident relationships, but doesn't fully define their location. And if you had the fully defined sketch button on your toolbars, you can easily just go ahead and select that, and that will go ahead and take care of adding relationships. As you see, there's horizontals and verticals on this one, and then even a dimension to fully define the position. But these points are now very suitable for dropping, say, hole wizard holes, or any other type of thing that you might want to snap to those particular points. So all those work pretty nicely. Okay, let's head back out, and we're going to talk a little bit about patterns now. Now, patterns themselves can be used for obviously very simple things or very abstract things, depending on whether you use basic linear or circular patterns, or whether you use things like curve-driven patterns, sketch-driven patterns, or fill patterns, which are another exotic way to do this. I'm going to go ahead and start off with just a basic linear pattern, and you're going to quickly see just exactly how powerful a simple seeming addition to this tool happens to be. What we have here is a basic rail. Now the rail, of course, has a hole that we have down here, and then that hole was linear patterned. In this case, it happens to be 30 instances. Now, it's a great cut feature, but what happens when we take this rail and we change its dimension? Let's drop that from 1800 down to 800. Well, now what we get is a failure for the linear pattern. If a cut feature can't find a body to cut, the cut feature fails. So let's go ahead and edit this pattern. Now, since the beginning of SolidWorks, we've always had the spacings and instances as the control for how you do a pattern. How many do you want? What's the distance in between those? Well, now we have this new one called up to reference. And what this effectively does is it really replaces what could be between 3 and 6 equations to accomplish what I'm about to show you here. And it has to do with controlling the spacing between these instances and maybe when new ones are going to show up based on the length of this linear slide rail. So in this case, what we're going to do is two things. First of all, I'm going to add the up to count, the reference. In this case, it could be a face, an edge, or a point indicated by this icon. So we're just going to say up to this point. Now by doing that, what we get now is a pattern that's going to live just within the domain of the starting face and this endpoint. On top of that, what we have also is an initial spacing. If you look over here, this is 25 millimeters off the beginning of this rail. Now 25 millimeter start is probably what we're going to want on the other end too, so we want 25 millimeters down here. And I could easily type in 25 in this offset distance box, but it's really easier or better for the system if I just make this an equation. Now equations can happen just by hitting the equals button. As you can see, the tooltip pops up and tells us that. And when you hit equals in any dimension dialog box, you'll get all logarithmic functions, the file properties we calculate, and everything else within the software, global variables that you might have added. Well, in this case, I'm going to be very simple. I'm just going to say that this dimension equals, and then click another dimension on screen. So now D4 at sketch 2 and D4 at sketch 2. We change one dimension, we effectively change both offset ends. Okay, so that being the case, we have 60 millimeters up to and offset from an endpoint. So here's the effect that you get. Now when I start to grab this slide and drag it out, as I get 60 millimeter spacings plus 25 millimeter offsets, new holes will appear. So this is a very intelligent pattern when it comes to the method that it's created, first of all, but just the fact that this part as a configurable type of part can be used in an assembly of varying lengths, and you'll get an instance count update proper for those individual lengths. Now this isn't the only way to define this. If we go back into that linear pattern, instead of it being defined by the distance, we could also define it by simply number of instances. Now using the same references, what this is going to do, say we've got 25 of those, is it's going to automatically change the spacing based on the overall length. So here we need to keep 25 of those, but as I go ahead and start changing the overall value of this, it's going to update the spacings to continue to keep those equal. So really both disciplines of whether common spacing, variable instances, or common instances, variable spacing need to be addressed. I want to take this to a different direction here. We're going to show you where editing a feature doesn't hurt you in the pattern instances anymore. We've got a single bodied part currently. It's just a single merged solid. And this happens to be a saw blade with saw teeth. Well, I'm going to edit this sawtooth feature and turn off merge results, which will then turn this into a multi-body file. Well, this tooth as an extrusion, as a feature, was patterned. If we take a look now in the feature manager, we now see that that pattern breaks. And the reason being is because the carbide tooth that used to be a feature is now a body. On previous releases, we'd have to delete this feature and redo it, which could be a really big problem if there's a lot of children beneath that. But here, we can now go ahead and edit that pattern feature, and we have the controls to be able to say, I don't want this to be a feature pattern anymore. Instead, I want it to be a body pattern. That way, anything related to this is still going to update properly, and we can then we can really nimbly change from a single body part to a multi-body part and not really hit ourselves with a whole bunch of editing that might have to take place. So really simple, but that one there is super, super effective. We're going to change gears a little bit to get to more abstract patterns. I know probably nobody on the line here creates these colanders, but this is really to show you a varying type of a pattern that we've created based on tables. So we've got a hole pattern out here. That's a pretty simple one, but we've also got a slot. Now this slot is then the seed feature for the pattern that you see here. And I want to show you how this pattern actually gets generated. So let's take a closer look. I'm going to grab the slot, and under our pattern tools, we now have a new pattern feature called the variable pattern. By selecting this, it's going to walk us through the features that we want to pattern, and then maybe some reference geometry also used to drive this feature. We can insert those either pre-selecting like I've done here, or after the fact right now. But essentially, this pattern is generated by using a table. Now the tables can be pretty simple, they can be pretty elaborate. The table that I'm going to use here is going to drive 3 dimensions, and we're going to do that by selecting those values now. What I want to do is I want to drive this angle, this offset distance of where the slot is from the center point of our colander, and then the length of the slot itself. And all those are gray because they're based on the feature itself. We're going to add 1 row to this table and see how things look. Now I want to change the angle first of all. I'm going to change it by not really thinking too much and simply typing in 360 divided by 20. Hit enter, and just like Excel, you're going to get the actual math value of that. These other 2 dimensions, not quite as sophisticated. I'm just going to click and change each of those. Once I do that, if we simply update the preview, what you'll see here is the additional instance right up here to the top. Now if that looks good for you, what we can do is then go ahead and really populate this thing in a very big way. To do that, I'm going to add 18 additional rows. Now these rows are all filled out based on the initial instance value, but using Excel-like functionality, I can populate these pretty quickly. So down here I can grab the 0 and the 18, and just like Excel, if you grab the corner of the cell and drag it down, it will increment them up based on the transform between the 2 cells that are selected. So very quickly I can add in 18-degree increments for each instance. This part over here is not quite as sophisticated. I'm just going to right-click and copy those, and then paste, paste, paste. This will be fairly repetitive. You only have to paste so far. In this case, I'm going to take it only down to the 8th row and simply copy and paste the additionals of those. That said, when we update the preview, now the entire chart takes effect, and this is what we see on our part. So each individual instance being driven by an individual row within this table. So once we say OK to this, we get a very elaborate pattern, but based on a pretty simple input. Now this thing really is quite nice when it comes to the feature result itself. What you'll notice here is that it's not just a feature, but it's actually got several instances within that feature. So if I wanted to click on any individual instance, I can actually action on those individually. I'll change the length of one instance versus the other. It's as if I changed the length of that feature on the table. If I want to go ahead and take any feature instance and suppress it, it's going to suppress just that instance, but not the variable pattern feature. Or, likewise, if I take a feature and simply hit delete, it's as if I went ahead and deleted row 3 or instance 3 from the table, but does not delete the entire pattern feature. So that one's quite sophisticated. The whole pattern that we have there is actually just a basic hole. We have a circular pattern of 36 instances, and with each individual setting for this, we've simply changed the diameter of the hole pattern and the number of instances of those holes. A few more that are really elaborate here. We're just going to go to our football spikes in this case. We have a variable surface. This is a boundary surface, but it could be imported geometry. And we've taken these spikes and we've created a variable pattern off of this initial seed feature. Now the seed feature was made in a very smart way, a smart way that's going to be effective with this complex face. It was built by putting a 3D point coincident to that face. Now what that means is as this feature gets patterned, that 3D point has to stay coincident to that face. On top of that, there's a plane tangent to this face through that point. So by patterning both of these, we'll start to get that these spikes are going to change to stay normal to the face as they get patterned. So in fact, the pattern itself has nothing to do with the orientation of these. It's all the smartness of the way the plane in the initial instance was created. From there, it's just an extrude, a cut, and a fillet. So with each of these instances, and I'm going to show you the actual table for this, all we're really doing on this is simply changing the XY position, the angle of attack, and then the length of each of those spikes, because you see the ones in the back are 24 and the ones in the front are 18 millimeters. So what that'll do is give you a very effective pattern, quite complex, but all built off of one single seed input. Gives us also the ability to individually grab a dimension for one of those instances and simply change its position independent of all the rest. As it moves to the left, it'll actually tilt back slightly. Kind of hard to see during the rebuild, but because those planes and points have to stay normal and tangent, those are going to all change the orientation and shift the position of those spikes. Last one I'm just going to pull up just to show you what the feature looks like is another shoe, but this one's a bit more complex when it comes to the cutouts that we've got here. This is a spline and a sweep cut, and all we're doing is actually changing the spline shape as we're moving it along. So you see that the spline goes from more of a mountain type of a shape to more of an arc shape as it transitions from one end to another. And then we're taking the depth of that cut and modifying that. So some it goes part way, looks like this, and some it goes twice as deep. So very cool. Really, the applications for this are open-ended, nearly endless, but very nice functionality added to our pattern tools. Let's talk about assemblies. Probably one of my favorite things to show, because there's two of the top 5 enhancements that I've always wanted within the product within this demonstration set. And one of which we're going to start off with is a brand new mate tool. Let's just hop right into it. So what we're going to do is first just go ahead and simply add a mate. Now by selecting these faces, we'll grab the one on the back there very simply and the one on the front here. By pre-selecting and clicking your mate tool, what we'll get is a coincident relationship. And obviously this part would then be able to slide vertically and horizontally. But we've got a brand new advanced mate called the Profile Center Mate. And as soon as I select this, what you'll see is these two profiles basically go right on center with each other. Very cool. Now it's also it's more or less a dual mate. Not only do the profiles center, but it also keeps those faces coincident to each other. And I'll flush that out a little bit more for you in just a second. When we're dealing with prismatic faces, you have these orientation buttons that pop up that allow you to roll this into a different position. But if you have it in the ballpark before you put the mate on, of course it's going to go in more of a predictable way. So this gets us essentially a with mate vertically and a with mate horizontally and a coincident mate. So if I was to go ahead and take this piece and change its size, just rebuild that, you'll see that those mates stay on center with each other. If I go ahead and take this plate and I change its position altogether, just drop that down a bit. Of course, you'll see that plate stays completely on center with the rest of the geometry that's there. So that's just the beginning of this. We can also use the Profile Center Mate for fasteners. Now these fasteners are completely underdefined. They have no mates whatsoever. I want to be very clear on that. If we go to our Mates tool and use the Profile Center Mate under Advanced Mates, you can do this by selecting the edge of the circle and the face in the hole, and the edge common to the circular and flat face on the fastener. And you can see that it will auto-center and put a coincident on that. So that's effectively 2 mates in one. On top of that, though, when it comes to fasteners, you can also lock the rotation. What this does is a fully defined fastener with one single mate. And for any of you that do special machines, large assemblies, use a lot of fasteners, I hope you're clapping at your seat right now, because that one there is huge for performance. I'm going to do this one more time. Mate tool, Advanced Mates, Profile Center. And all we're going to do is grab the edge of the bottom of the fastener, which is common to the cylindrical and flat faces, and same thing over here on that hole. So a coincident, a concentric, and a locked rotation all built in to one single mate tool. Once again, 2 fully defined fasteners, 2 single mates. So that one there is tremendous. Now backing out of this just a little bit, we've also got another mate situation, and it has to do with this arm. You can see that that's concentric, and really that's about it at this point. So I want to go ahead and fully define that. I typically do this using a with mate. Now with mates are easiest done by pre-selection. I'm going to control select the bottom faces of these 2 pieces and that piece, and then the top of what is effectively the tab. But I don't really know what the tab or the widths are. I don't really think about that too much, because by pre-selecting these faces and going directly to your mate tool, it automatically jumps you to the with mate and fills out what the selection should be automatically. Now at this point it's more or less a centering mate. In fact, that's the setting for it. But we have other settings we can actually use. With this we can actually call it free, which almost makes this with mate effectively a limit mate. Because as I try to move this part, you'll see that those faces have to move only within each other and can't go outside each other's boundaries. By editing that mate, there's also one more setting that I want to show everybody, and it has to do with being either a percent or a dimension distance between those. And if I say I want to put these at a distance, let's just say I want to do those as 20. These 2 faces up here are now 20 millimeters between each other. We flip the dimension, now we've got 20 millimeters down here. But centered and free, probably mostly what's going to be used there. Very cool either way. All right, over here on this end, I've got another mate that I want to deal with, and it's this angle mate. Now, many of you that do special machines and do angle mates have probably experienced a situation where mates will flip directions on you. So in this case, what I want to do is go ahead and mate these up, but I'm not just going to do an angle mate. I'm actually going to do an angle limit mate. What happens is when these 2 faces that are mated up now at roughly 90 degrees, if we change that dimension over 180, normals can flip, and then the dimension reads the opposite value, and that can be very difficult and unpredictable, of course. Well, now what we have over here in our dialog box is this area called a reference entity. With the reference entity selected, I can go ahead and grab a cylindrical face, and it will pop up this quadrant selector tool. Now this allows me to go ahead and select where the reference of that dimension is, and it will rigidly keep it in that orientation from this point forward. So if we want to do an angle that happens to be 45 now, but is maybe top end 90 and bottom end 0, that's going to give us the dimension that we're looking for, and it's always going to keep that reference relative to the quadrant selector that we just used. We've also got some compound movement here. You can see I've got some rotations because of the arm, and then I've got some rotations on these parts here as well as this twist here. This is something that if you want to move individual components can be a little unwieldy, but we now have a tool built in to move components that allows you to temporarily group and fix things. So if I want to temporarily fix, say, this part here so it doesn't move, now when I resume drag, it's as effectively as if I went ahead and fixed the part. Although if you fix a part, you might inadvertently overdefine things as well. But now we're only moving these couple of components. You can also group them if you don't want these two to move individually, but in other words in unison. We can simply select that box and add those two components to it, and now they will move as one joined group instead of an individual. You see that we now have that angle limit mate working very nicely there. Okay, let's go over here. I want to put in two more of these control knobs, or excuse me, one more over in this area. So I'm going to do an insert component function. When you do insert components and you browse to your component now, what you're going to get is a pre-created positional tool. So if I want to put this in place, maybe I want to rotate or orient this thing a little bit more properly. When you put it in there, you get this 90-degree or the ability to change that angle, but you can roll this part around in different positions and get it in the ballpark. So once you've got it in the right spot, when you click in the window, it will then insert in that orientation. Nothing big on this one here. I'm just going to make a pretty quick tangent mate here. All right, our part is now in place. So I want to run an interference detection. Under my evaluate, we'll run interference detection, and we'll calculate the entire assembly. In an interference detection, based on how you model things, you might get additional interferences here that aren't really relevant. Things like fasteners, where you have a tapped hole that doesn't have a tap and a fastener that doesn't have threads, those of course are going to overlap and interfere. You can always go ahead and address those by creating either a matching cosmetic threads folder or a fastener folder. They'll take any interferences related to fasteners and simply put them in that folder and segregate those. Other ones that might be here, it can be difficult to sift through, and this could be a situation where if you have thousands or hundreds that are very tiny, you might not be able to see them in the proper orientation or list. So when you right click here, you have some options to be able to sort largest to smallest or smallest to largest. You really want to see the largest ones, of course. Smaller ones, well, those might result in the fact that you model things like an O-ring like we have out here. We don't throw a compressed O-ring into a groove, so we get an interference as a result of that. But you can also go ahead and not only sort them in a particular way, but you can right-click and ignore all of them smaller than a particular size, the one that I've right-clicked on. And then that will flush out any of those insignificant ones and really leave only the necessary real ones for us to deal with. Now this one does have an interference, and I'm going to deal with that interference right now. And we're going to do it by cutting the center of this hole away. I've already got a feature for that, so we're just going to use some demo magic to show that. But what I've done is a typical grinding or cutting operation in order to hone this hole out. The problem happens, and this is probably my number one or number two favorite enhancement here, is when you go back to that assembly, what we see here is just a bloody mess. We have mates that are now broken, and they're broken because the cylindrical face on the inside is what I used to mate to, and now it's gone. Well, here we'll do a typical operation. This is 3 mates that are broken. This could be 50, frankly. But if you edit one of these mates, it's going to show you the missing silhouette of what happened to be there before. But if we simply replace that with another face and say OK, we're now prompted with a box that says, hey, a bunch of other faces were also broken relative to this missing face. How'd you like to replace all the mates with this new mate reference? So by simply saying yes, all of the problems related to that mate broken or that feature being gone will now be resolved instantly. So once again, special machine users or anybody that's really had to go through the process of fixing a bunch of mates because of a necessary edit, this is going to save you an absolute, untrackable amount of time, I would hope. So fantastic little function there. So one last thing that I want to do on this one is I just want to go ahead and delete this part. 2 things actually. I'm going to delete this part. When you delete components in an assembly, you now have some choices of whether you delete the children or not. So you have some choices to say, you know what, I have 3 mates that are here. Maybe I don't want to delete those, and I just want to reassociate those mates with whatever part I end up putting in to replace this. So it's not just a one fell swoop thing anymore where everything related to a part gets deleted. You do have some choices or recourse to that. Last thing I want to do happens to deal with these control knobs down here. Now these are 3 of the same files. Control knob, control knob, control knob. And many times in special machines especially, you might want to individually edit one of these multiple instances of a common part, or if you have brackets that you made and you made 50 of them, you might want to edit 1 or 2 of those. Well, it's hard to do because you have to save a part and then replace and do some other operations. Here what I can do is simply right-click on the part that I want to make a one-off and simply choose a choice called Make Independent. What that'll do is then go ahead and save the component with a new name for us and simply replace it in the assembly. I'm just going to call this one Go to Webinar. When I click on Save, what it now does is it basically swaps the file out, does a file save as copy, and then replaces it for us and puts us in. We can now go ahead and effectively edit this component without affecting these 2 control knobs in any way. All right, let's get into our last operation here. We're going to talk a little bit about sectioning and exploded views. Now, sectioning in a 3D part or assembly has always been something that we've done based on some planes or faces. Well, when you do a section, you have choices of making single or multiple planes effective. So by grabbing your section view tool, planar selections is the way we've always done this, you'd simply grab a plane on your assembly and orient that plane wherever necessary. You could then go ahead and add a second plane, different orientation, and either go ahead and orient that or now twist it with these orientation rings that we now have on this. So you can rotate this quite easily. You can also go ahead and select a third section in a different direction and you'll get the cumulative section of those 3 planes being on. Now one of the difficulties with this is if I switch the directions on any planes, I'm effectively getting the opposite section. And it's not always the easiest thing to get the section that you want. So we've added a new input here called zonal sectioning. Zonal sectioning would allow me to go ahead and take whichever zones are created based on what is a mutual trimming essentially of those 3 planes. So if I want to show a section that has this top corner, I pick on that box and you see that that gets sectioned. If I want to add in this side, we can also select that and now we're cutting all the way through. But with this I can also go ahead and add in additional zones on the back side if I wanted to. So now we've got some zones on the front and zones on the back. Now this won't really work unless you have graphics only selection turned on. This is more or less a zero thickness geometry situation. So with what we've got here, if I accept it using graphics only section, we can actually see this very complex section view based on those 3 zones that I showed to have on. Now the sectioning is one of the things I wanted to show, but the other is exploded views. With this assembly, I want to go ahead and take everything that we've got here, and we're just going to run a brand new exploded view. For the entire history of SolidWorks, and really most CAD systems, exploded views have always been linear transitions, translate a part from one direction to another. When we have these parts here that are in a star pattern around a circular body, we would have to go ahead and do the linear transitions on each of these one at a time, 5 separate operations. Well, now we've added a new feature called the radial explode. What that allows me to do is select components on screen, which this time I'm going to do by actually using a selection set I've already created. Here in an assembly, I want to pick 10 fasteners. I only want to pick them once and never want to have to control pick them again. So saving them as a selection set saves me a boatload of time the next time I want to pick those. Then we're going to go ahead and do a radial section. Here we need this option, explode direction. By grabbing a cylindrical face, we are exploding radial from the axis of that cylindrical face. And now by grabbing my explode line, you'll see that I'm actually exploding those all out in a star pattern off of that central axis. So using another selection set that I've got, let's do the same thing with these arms. Same thing here with our central axis, and let's just go ahead now and explode those out. Now there's also enhancements that have happened with linear explodes. When you have components that are mated in such a way that they are coplanar to each other, linear explodes now automatically group those components together when you're using autospace. So as I start to drag these components out, what you'll see is the washers and the nuts are all completely coplanar and exploding at the exact same distance to each other. Now one thing you might not have known about this tool is that we're in the middle of autospace here. We can change the spacing in the middle of this, we can also sort things, take them into a different orientation, maybe drag them in a different direction, put them opposite of each other, and simply reposition these to any little minutia distance changes that we might want to do. But it groups them nice. They're all in the same coplanar faces, and they wouldn't come out to 5 or in fact 10 different distances because they happen to be 10 separate components. The side benefit of any exploded view that we do, of course, is the fact that these explodes animate, and the animation happens with this type of a feature as well. It's a simple step, and that step is going to explode in the proper order within the assembly itself. So at this point, that concludes the things that I was wanting to show today for everybody. I want to go ahead and just take a look over at my GoToWebinar tool here and see what kind of questions we might have had. I know we had a bit of an audio issue there back just a little bit. So let me make sure that that's all taken care of. Yep, looks like the audio is restored, so everybody was chiming in on that. I do appreciate that, guys. If anybody has any other questions that you'd like to go ahead and throw in that questions tool, I'll try to answer them now, or we'll just go ahead and send you an email after the fact. We'll go ahead and get this thing tidied up and finish the recording session, and from there we'll go ahead and throw that up onto our website and hopefully have that up there within a couple of days. So with that said, let's see what we got here. Can you import the bill of materials into the assembly to an Excel file? Yep, it's exactly the same table. So the question that we got there from Jacob, it's the same bill of materials templates in an assembly that we use in the drawing, and by right-clicking on it, you can save it as an Excel file just as you can from a drawing. Side benefit also is if you define the bill of materials inside of a SolidWorks assembly, that assembly bill of materials can also be the driving assembly in Enterprise Data Management, aside from the way that Enterprise would calculate things. So a couple of nice things that you can do there as well. All right. I do appreciate your time once again. Everybody have a great afternoon. Enjoy the last few minutes of your lunch. And hopefully join us on January 9th for the Part 2 session of our What's New in SolidWorks 2015 webinar. Once again, I appreciate your time today. Thank you very much, everybody. Have a great afternoon.